4, this is all about completing the square. This is our third method for solving quadratic equations. Our goal is to be able to solve a quadratic by completing the square and to be able to simplify radicals. Both of these are something we're going to have to do in this process. I'm going to give you all the steps and then we're going to walk through it. So the steps to completing the square are: first, move the constant to the other side. Second, write in the blanks, and I'll show you what that means in a second. Third, take half of b and square it and fill in the blanks. Fourth, we combine. Fifth, we factor. Then we square root, and then we solve. Take a minute and pause this, write down these steps, and then we'll go through a couple of problems to show you what I mean by actually doing this. So here we have x squared plus 4x plus 11. The first step that we want to do is to move the constant to the other side. Remember, the constant is the number that does not have a variable. In this case, it is 11. So I am going to move the 11 to the other side by subtracting it. Okay. My next step is to write in some blanks. And what I mean by that is to just fill in some spaces here. Okay. Write in those blanks. Those are going to come into the process later, but it's helpful to set up the process this way so that you know what you have to fill in. Okay. Next step is to take half of b. So b is 4. I'm going to take half of that, which is 2, and I'm going to square it. 2 squared is 4. That's the number that goes in the blanks. Always the same, and it's always plus. Okay. So I took half of b. Half of 4 is 2. 2 squared is 4. That's what goes in the blanks on both sides. Now I am going to do the next two steps together. I'm going to combine and factor in 1. So on the left-hand side here, I'm going to factor what multiplies to be 4 and adds to be 4 is 2 and 2. Okay, I'm going to end up with an x plus 2 squared. You will always end up with a squared quantity here. That's the whole point of doing this. It's called completing the square, so that you have a squared quantity. Okay. So the number that is half of this should also always be the square root of this, and that number is what goes in the parenthesis. Then combining, I'm going to combine the negative 11 plus 4, which is negative 7. My next step is to square root both sides. On the left, when I square root, I'm left with x plus 2. We've talked about this before, that the square root and the square undo each other. On the right, remember that I always have plus or minus when I'm square rooting. I'm going to have an I because the radicand is negative. And then I'm just going to have the square root of 7 because that cannot be simplified. My last step is to get the 2 to the other side. And I'm going to do that by subtracting. So I end up with negative 2 plus or minus I times the square root of 7. That is my final answer. This should look somewhat familiar. We did problems similar to this when we were square rooting, solving by square rooting, which was our first method. However, we have to come up with the square part so that we then can square root it. That's what completing the square is all about. Okay, let's try another one. To get this problem here, again, my first step is to move the constant. So I am going to subtract 12 to the other side. I like to a lot of times put my blanks in when I do that and do those two steps at once. It saves room. So now I'm going to take half of b, so half of negative 4 is negative 2, squared is still a positive 4. So I'm going to put a 4 in both of those blanks. Now on the left side, I'm going to factor. And remember, I'm looking for the number that's both half of 4 and the square root of 4, which is 2. And I know that it's minus because it's half of this negative 4. On the right-hand side, I'm going to combine. Negative 12 plus 4 is negative 8. Now I'm to the point where I can square root both sides. So I'm going to do that. On the left, I have x minus 2. The squared and the square root undo each other. On the right, I'm going to have an I again because this is negative. But 8 is a number that divides out, so I'm going to make a factor tree real quick because I know that there are pairs here. So I'm actually going to have 2i outside the radical, and then I have that leftover 2 that stays inside. My last step then is to move this 2 here to the other side, which means that I have a positive 2 plus or minus 2i square root of 2. A lot of 2's here, and none of them can be combined. This is my final answer. I hope you're kind of starting to get the hang of completing the square, seeing the process and the different steps. We want to kind of keep going. Remember that when you're completing the square, a has to be 1. If it's not, then you have to divide. So looking at this next one here, a is not 1, a is 2. So that means that I cannot complete the square until I divide everything by 2. I'm going to do that real quick. And I'm going to leave this as 3 over 2. Improper fractions make life easier when we're working with quadratics and polynomials and different things. So try to leave it as an improper fraction, because when we end up square rooting, which we will, it will be easier for you, okay? So let's start our process now. We're going to move the constant, and I'm going to put in the blanks at the same time. Notice I moved the 3 halves. I just changed its sign, made it a negative on the other side. I'm going to take half of 4, which again is 2, and I'm going to square that and put that in each of the blanks. Now I'm going to factor. So x minus 2 is what goes in here. And then I'm going to add negative 3 halves plus 4. 4 is actually 8 halves, because 8 divided by 2 is 4. And negative 3 halves plus 8 halves is 5 halves. Now I'm going to square root both sides. On the left, I have x minus 2, and on the right, I have plus or minus the square root of 5 halves, which, when we simplify, we can break this apart into the square root of 5 over the square root of 2. Neither one of those has a square root, but we are not allowed to have a radical in the denominator. So we're going to do what's called rationalizing, and we're going to multiply, whoops, that's not a 2 square root. Sorry, I was talking and I can't write and talk at the same time, I guess. Square root of 2 times square root of 2 is 2. So this becomes x minus 2 equals plus or minus square root of 10 over 2. And my last step is to add the 2 to the other side. And there we go. You can leave it like that. Or if you really wanted to, you could put it all as 1. To be honest, it doesn't really matter. Okay? So this one we had to simplify first by dividing by that coefficient so that we could complete the square. And then we go through the whole process again. And yes, it does give us a fraction, which is not always fun, but we can do it. We are good mathematicians. We know how to deal with fractions, and we can handle these kind of problems, okay? So hopefully you're kind of starting to understand completing the square. I know we will go over it more in class, but this is just a good first look at completing the square and the process that it takes.